In this video, we're going to look at 3 different types of problems that you can be asked about tangent lines and their relationship to a circle. So the first type of problem is one where they ask you to find like the perimeter of a shape that has all 4 sides tangent to the circle. And so the property that appears here is that a tangent line intersecting with another tangent line from a circle, those 2 segments are going to end up being equal to each other. And so that applies to all 4 parts here. So that segment is going to be equal to that segment. This segment here is going to be equal to this segment here. And then finally, this segment here will be congruent to this segment here. So with that information, what we can do is we can figure out what all the missing pieces in this shape are so that we can find its perimeter. So first off, I look at this part and I say, okay, that's 9, so this side must be equal to it. This must also be 9. And I say, okay, this side's 4.4, so this side has to be 4.4. Now, I don't have anything for this orange side over here or this pink side, but what I can do is I can use the concept of that this blue segment here plus that orange segment there has to equal this 12.5. So what I'm going to do is take 12.5 minus 4.4, and that tells me this orange piece is 8.1. Now if that piece is 8.1, this piece needs to be 8.1. Then we use the same concept down for this 12.5 and say, okay, well I have 9, I want 12.5, so I'm going to subtract and figure out that this is 3.5, which makes this piece 3.5. Now, from here, it's just adding up all the pieces to get the perimeter, but what I like to do is add up and figure out what this whole length is. So like this side would be 13.4, and then this side would be 11.6. And then from there, I go ahead and I'll add up all the different sides. So we get 12.5 plus 13.4 plus 11.6 plus 12.5. Now you can just put all that into a calculator and get an answer. So I'm going to do some math here real quick. 6 plus 4, that's going to give me 10. Carry the 1, and we get 50 for a total. So the perimeter here is simply that, 50. Okay, so that's one type of problem we can get. Another type is this kind of problem here, where it's asking us to determine if a line is tangent to the circle. Now, what we have to remember for a problem like this is that if I do have a tangent line, so if AB is tangent, then it has to be perpendicular to the radius. So if this is not a right angle, then it's not tangent. To prove this is a right angle, I need to show that this is a right triangle. And I can do that by using the Pythagorean theorem. You know, the a squared plus b squared equals c squared. And so all I need to do is put in the numbers that I have from this shape and see if the Pythagorean theorem holds true. So what we're going to do is substitute in our values. So I see that 8 and 14, those are my leg lengths, and I know that this side here is my hypotenuse. So that has to be my c value. So let's get those values in there. We get 8 squared plus 14 squared, and that should give us, now to get the length of the hypotenuse, I have to take this 9, that's just this outside piece, plus this inside piece here. Now I know that piece is 8 because this piece is 8, and they're both radii of the circle, and the radius always has to be the same. So this whole length is going to be 17. Now from here we're going to have to simplify this out and see if we get the same value on both sides. So we take 8 squared and get 64, take 14 squared and get 196, and take 17 squared and get 289. So now we're going to combine these terms here, and we're going to get 260, and that does not equal 289. So AB is not tangent. Because the Pythagorean theorem doesn't work, therefore this is not a right angle. Okay, same concept for number 12. Let's jump down to this last one. And really this is the same kind of concept, but it's just actually using the Pythagorean theorem to find the missing side that would make that tangent. So, if you look at this one, our tangent line is this 8 here. And we have this line here that crosses and we get a 90-degree angle there. So that means this must be our hypotenuse. So we're just going to use Pythagorean theorem, and Pythagorean theorem says a squared plus b squared is equal to c squared. So all we have to do is substitute in our values. Let's call 8 our a value. Now our b value, this 4.2 is just the radius. So to get that whole length, we need to double that and make it 8.4 squared. And then finally, our c value we don't know, that's our question mark, and we'll square that. So now we're just going to simplify this. We do 8 squared and get 64. And then we're going to do 8.4 squared, and that gives us 70.65. And that's going to equal question mark squared. Now we're going to combine these like terms here and get 134.56 equals question mark squared. And to solve this, we're going to take the square root of both sides, and we will get 11.6 for the value of our hypotenuse. So that is 11.6 there. Key thing here, a lot of people forget to double that radius to get that whole diameter. That's the line we're looking at. So that's the thing to focus on these problems. Make sure you're getting the whole length that's needed. So those are the 3 types of problems you can see when dealing with tangent lines and the circle. So I'm going to zoom out here. If you want to look at the rest of those answers for those types of problems, that's what you would have there. Okay, and that's all for this video.